The Arctic Ocean undergoes extreme seasonal changes. In the summer, the fresh water from rivers, melting ice cap, and permafrost does not mix with the surface seawater because of its density.
In the ocean, what matters for density is temperature and salinity. They are the primary factor affecting the density of water.
The waters are arranged into separate layers. This phenomenon is called ocean stratification.
The stratification of the Arctic Ocean is one of the key features about how that ocean works, and it gets stratified in a couple of different ways. It can get stratification from water that comes off land, or it can get stratified from the melting of sea ice.
Water density varies according to salinity and temperatures.
The water that has less salinity will lie over the water that is saltier. So again, both salt and temperature are important.
Seawater has a memory of its last contact with the atmosphere. Stratification has an impact on nutrient exchange between layers. In a near future, this could lead to a desertification of the Arctic Ocean.
L'augmentation de la température produit une couche d'eau plus chaude, qui est plus légère parce qu'elle est plus chaude, et qui limite le brassage de l'océan, la ventilation et l'apport de nutriments qui viennent des eaux profondes vers la surface.
Stratification influences greatly oceanic circulation. These are the currents that allow waters to circulate between oceans and define the climate of our planet.
And there are places in the ocean, very important places, both in the Labrador Sea near Iceland, where water are formed that are the densest formed in the world, and those go all the way to the bottom of the oceans. And they're part of what we call the conveyor belt.
En s'écoulant comme ça vers le fond, évidemment, cette circulation-là entraîne des eaux froides vers le fond, donc elle a tendance à tempérer le climat en quelque sorte, donc à empêcher que le climat soit beaucoup plus froid qu'il ne serait autrement.
With temperatures rising, we could imagine summers free of ice in the Arctic Ocean. If light penetrates the superior layer of the ocean, will there be an increase of primary production? Will the strong winds allow a mixing of the ocean layers and upwelling of nutrients which triggers the phytoplankton bloom?
Cette eau douce flotte à la surface de l'océan, crée une couche qui réduit le mélange, le brassage de l'océan, un brassage qui est très important pour ventiler l'océan et amener en surface tous les nutriments essentiels à la croissance des algues, par exemple l'azote ou le phosphore.
If the intake of fresh water in the Arctic Ocean increases, stratification should intensify. This could cause a drop of the phytoplankton biomass due to a limitation of nutrient transport towards the surface. These are the central questions that scientists are trying to answer. What stratification scenario will affect the future of the Arctic Ocean?